Hello, Math 140 students. This is your instructor, Cindy Enrique, and we're going to continue with Chapter 6, and we're going to pick up on Section 6.7, which is graphs of quadratic equations and functions. So we're going to be looking at parabolas. That's a quadratic function or an equation. It's degree 2. So we know that the quadratic equation can be written as the y is equal to ax squared plus bx plus c, or if you want to talk about function notation, our function notation, we just change the y to f of x. But really, we just want to pay attention to the exponent. The exponent is 2, so any quadratic is degree 2, okay? All right, so for this chapter, we're going to have parabolas that are either a positive parabola or a negative parabola. So this one is actually a positive parabola, and we can think of it as it being happy. Okay, because it is, as you can think of it, smiling at you. And then this other parabola, we can think of this as a negative parabola, and it's because it is sad. And you can think of this one as it's frowning. So think of it smiling, positive, happy, and frowning, negative, sad. Okay. So every parabola will have a line of symmetry about a line called its axis of symmetry. It's kind of like saying for your axis of symmetry that if you cut it down the middle, that this half of it will be identical to the other half. It's the mirror image. It's kind of like your face. Most faces are symmetrical. So if your left side of your face is the same as your right side of your face, and you can think of your nose as being your axis of symmetry. Okay, the blank is the minimum or maximum of a parabola, and that would be the vertex. Okay. So the vertex, and sometimes I call it the Vx for the vertex, it depends on whether or not you have a positive or a negative parabola. So here, because I have a happy positive parabola, I'm going to have a minimum for my vertex. And over here, because I have a sad negative parabola, my vertex is actually going to be a maximum. Okay? All right. The y-intercept is when x is equal to 0, and the parabola intersects the y-axis. So, for example, it wants us to complete the table of solutions and then graph this 2x squared plus 4x minus 2. So it's already giving us some values to plug in for x. So it's particularly giving us values of x. And so the equation that we're going to be plugging this into is that 2x squared plus 4x minus 2. So maybe I'll just do one of these, okay? So when x is equal to negative 2, I'm going to plug it into my equation. So I have y is equal to 2x squared plus 4x minus 2. So that x that I'm plugging in is negative 2. So when I plug that in, so I'm grabbing my calculator now. So 2 times negative 2 squared plus 4 times negative 2 minus 2. I'm going to get this as a negative 2. So now I know one of my first values. So I'm going to keep doing that, and I'm going to get all of my different values here. Okay. So go ahead and press pause and plug in all of these values for x into your equation. Okay, so I went ahead and plugged in all of my values. So I did it for x is equal to -2, x is equal to -1, x is equal to 0, x is equal to 1, and x is equal to 2. So I'm just plugging in all of those values into the same equation. So now I have all of my y values. I got them from plugging it into the equation. And now I'm going to graph these points onto my graph that I have here. So I have -2, -2. I have -1, -4. I also have 0, -2. I have 1, 4. And I have 2 to 14, which is kind of out there. So my graph more or less is going to look like this. So there is a sketch of my graph. Okay. All right. Now, down below, for example number 2, it says use the graph of the parabola to determine the coordinates of the vertex and the axis of symmetry. So here, we're not really doing any algebra, we're just making sure that we are able to understand our vocabulary, okay? So we want to make sure we know what the vertex is. So vertex. Remember, the vertex is going to be either your minimum or your maximum point. So the vertex here is going to be a maximum. So that point right there, it looks like this is 1, and this is 1, 2, 3. So this is 1, 3. So I can say that my vertex is the ordered pair 1, 3. Okay? So if it's specifically asking for the axis of symmetry, the axis of symmetry and you actually have to say x equals, and what is this x value? Well, the x value is 1. Now, if you can think about it, when you graph it at that x is equal to 1, that's the point where it's going to be symmetric. It's the mirror image, okay? All right, so let's go ahead and do this for part B. So here, looking at this, it looks like I have my minimum point. So let's see what that value is. So this looks like it's -1, 1, 2, 3, and -3. So it's -1, -3. So my vertex here is -1, -3. So I'm going to have my axis of symmetry. So remember, that's going to be an entire line. And it's right at the x-axis. So whatever this value is, that's what you're going to write. So it's x is equal to -1. Okay? All right. So hopefully that helps you understand the vocabulary a little bit more regarding vertex and the axis of symmetry. So a parabola in standard form is written as ax squared plus bx plus c. So there's a little bit of a typo here. That should be bx. A little bit of a typo. So ax squared plus bx plus c. The vertex is the lowest or highest point of the parabola. The axis of symmetry is the vertical line that passes through the vertex. It is written as x is equal to some number, whatever that number is. We can graph a quadratic function by plugging in its values in standard form. Okay. So that's everything that we kind of summed up what we just did. Now the new information. The quadratic in vertex form, so this is new vocabulary, the vertex form is written as this. It's written as a x minus h squared plus k, where the vertex is hk. Okay. So this is a new way of approaching this problem. It's already given to you in vertex form. So here, for the examples below, it says identify the vertex of the following quadratic functions. So I know, according to this, that this value right here is my h, and this value is my k. So my vertex is going to be the ordered pair where it's h, comma, k. So look at how this h here is a negative h, and this is a positive h. So this is negative, and this is positive. So that means that the h value is always going to be the opposite sign. So if it's negative, it's going to be positive. If it's positive, it's going to be negative. So if this is a -3, then it's going to be a +3. And the k value goes in directly. So that's 4. Okay, so let's move on to the next one. I know according to my formula, this is h and this is k. So my vertex is going to be the ordered pair h and k. So is this going to be a +1 or a -1? Well, if it's the opposite sign, it should be a -1, and your k value goes in directly. So that's going to be a +5. So keep moving along. I have my h and I have my k. So my vertex I know is going to be the ordered pair where I have h and I have k. So if that's a -3, the opposite would be a +3. And the k value is a -1. And for that last one, I have my h and my k. So my vertex is going to be the ordered pair h and k. So if it's a +3, the opposite of +3 is -3. And the k value gets directly copied. So that's going to be a -2. Okay. I hope this is making sense to you guys. So now we have some practice problems. So we have practice problems 1, 2, and 3. So we want to find the vertex. That's going to be the first thing. And we want to know whether or not the vertex is going to be a maximum point or a minimum point. So remember, if I have a parabola that's positive and happy, that tells me that this is going to be a minimum point for the vertex. If I have a parabola that's negative, then that vertex here is going to be a maximum point. Okay. It's going to be a maximum point. So the way we're going to tell whether or not it's going to be a maximum or a minimum point is going to be this value over here. So this value, whether it's positive or negative, it's going to tell me whether it's going to be a minimum or a maximum. So remember, this is when it's positive, and this is when it's negative. Remember the happy face, it's smiling at you. And negative, you are frowning. It's a sad face. Okay. So for number 1, I can see that that value is 4. So I definitely know this is going to be a positive, happy parabola. So I know I'm going to have a minimum point. And I can also tell you what my vertex is going to be. Well, I know I have my h and my k. So my vertex is going to be the values of h and k. So that's going to be a +6 and a -9. Okay. So now for the next one, I see that this value here is a -2/5. So that tells me that I have a sad parabola because it is negative. So that tells me that I'm going to have a maximum point. And I can also tell you what my vertex is going to be. I know I'm going to have my h and my k values. So my h is here, it's the opposite, so it's a +2. Let me try to write that again. It is a +2. And my k value is here, and that's a +5. So my vertex is 2, 5. And for number 3, it's the same process. I'm going to look at whether it's positive or negative. that is a positive parabola, so I know I'm going to be having a minimum point. And I can tell you what my vertex is going to be, since it's just the h and the k value. So here my h value is going to be a -3, and my k value is going to be a -1/4. Okay. Well, let's see what the next problem gives us. It says that we're going to be graphing now these quadratics or these parabolas, okay? So the first thing we want to do is identify the vertex. So you're just like, okay, so I want to identify the vertex. That's going to be my step number 1. So step number 1 is going to be the vertex. So I know that's going to be my h and my k value. So here is my h, here is my k. So h is -1 and k is -3. So I know that the point -1, -3 is here on my graph. Okay, so I went ahead and graphed it. Now, step number 2. I want to know if it opens upward or downward. So this is telling me whether it's going to be a positive or negative parabola. So here, what is that value even though it doesn't say anything? Well, it can default to 1. So I know that I have a positive parabola. So this is going to open upward. Okay. So then for my next one, oops, sorry about that, guys. It looks like I'm running out of, okay. Sorry about that. It was just one of my computer notifications. So I know I'm going to be opening upward because it's a positive parabola. The next thing, I want to identify the axis of symmetry. So then my axis of symmetry, that's x is equal to the x value, which is my -1. Okay? And then it looks like now I'm going to determine the range. Use the graph to determine the domain and range of the function using interval notation. Okay, so it looks like I'm going to do that after I graph. So now to get the remaining points, I can just set up an x and y table. So to get points for x and y, so I already know that when I plug in -1, I get -3. So maybe I'm going to get a few more points here. So it just kind of depends on what you want to plug in. So I don't know, let's say I want to plug in 0. 0 might be a good one to plug in, so 0. So I'm going to have parentheses 0 plus 1 squared minus 3. So I'm plugging 0 into this equation right here, and I'm going to get a -2. So let's say I want to plug in 1. So I would have 1 plus 1 squared minus 3, and I get a +1. And let's say I want to do, I don't know, -2. Okay. If I plug in -2 plus 1 squared minus 3 gives me a -2. And let's say I wanted to do +2. Well, 2 plus 1 squared minus 3 gives me a +6. So now I have some points to plug in. So it looks like I have -1, -3, which I already had, 0, -2, which is here. I have 1, 1. I have -2, -2. And I also have 2, +6. Okay. I'm just going to try -3, just to make it a little bit more even. So if I were to plug in a -3 plus 1 squared minus 3, I get a positive 1. So negative 3, positive 1 is here. And you know what? I'm going to go one more, negative 4. So negative 4 plus 1 squared minus 3. That gives me a positive 6. So negative 4 and positive 6. And you just guess as many, or you put in as many x values as you need in order to see it. And sometimes you don't know until you actually start graphing this thing. Okay, so now I have my points, and now it wants me to do the domain and the range. So, okay, so if I'm thinking about the domain, it looks like I'm going to go from negative infinity to a positive infinity. So there is my domain, from negative infinity to positive infinity. Now my range, well, remember the range is going to be from the minimum value, minimum y value, to the highest y value. So that smallest y value from the vertex, it looks like it's negative 3. And if I'm going to the biggest y value, well, if it keeps shooting up, it's going to go towards my positive infinity. Okay. So now I have my domain, and I also have my range. Okay. So now I have a practice problems. So it looks like I am going to graph this function. So go ahead and press pause and work out this function to graph. Okay. Well, hopefully you guys worked out that practice problems. Again, practice problems are there to challenge you, and hopefully you guys are doing this on your own, actually pressing pause and trying to figure it out. So the answer is there to check your work. So the vertex I got as negative 2, positive 4. I noticed that my opening is negative, so it's going to be opening down. And then I just plugged in some values. I started at the vertex for the x values and kind of picked some values around there. I knew that when I picked 2, my y value was negative 12, and that's kind of off the charts. So I wanted to stick with smaller numbers. Okay, so now for the next part. We're going to be identifying the vertex given different forms. So we know that we were given the vertex form, that h and k. Now, if we were given the standard form, we can find the x-coordinate of the vertex using a formula. That formula is negative b over 2a. So here we want to identify the vertex. Notice how it's not given to us in vertex form. Instead, it's given to us in standard form, and we still want to find the vertex. So we are going to have to do some algebra. We are going to find the ordered pair. So the x-coordinate of the vertex, oh gosh, my pen is kind of running out of juice here, is going to be that formula, negative b over my 2a. So I want to make sure that I identify my a, my b, and my c value. So here it looks like my a value is equal to 1, my b value is equal to 8, and my c value is equal to a positive 17. Okay, so when I plug in my value, my negative b over 2a, I am going to have my value as a negative, and then I'm plugging my b value, and then 2 times my a value. So that b value here is 8, and my a value here is 1. So I have a negative 8 over 2, which is a negative 4. So for my vertex, I have a negative 4. That is my h value. Now I'm trying to figure out what my k value is going to be. So to figure out the k value, what I do is I actually plug in -4 into that equation. So I know that I have y is equal to x squared plus my 8x plus 17. Okay, so then that tells me that I'm going to be plugging in -4 into my equation. So when I plug in -4, let's see, -4 squared plus 8 times -4 plus 17 gives me +1. So I get this to equal to +1. So now I have my vertex. Okay, now I'm going to do the exact same thing for number 2. So I'm going to plug in my -b over 2a. So I want to identify my a, my b, and my c value. So a, or actually let's write it over here. So my a value is equal to a -2. My b value is equal to a +12. And my c value is equal to a -13. Okay, so the x-coordinate of the vertex, I know that's -b over 2a. So I'm going to have a negative, I'm going to plug in my b value, 2, plug in my a value. So here, my b value is 12, and my a value is a -2. So I am going to have as a fraction, -12 divided by 2 times -2, and that's going to give me a +3 when I plug it into my calculator. So my vertex, I do apologize, my pen is running out. I have 3 so far. That's the only thing I have figured out, is what that h value is going to be. So I'm going to plug that into my equation. So y is equal to -2 parentheses squared plus 12 parentheses minus 13. So that value that I'm plugging in is that h value, so that's 3. Okay, and that's going to give me the k value of my vertex. So I have -2 times my 3 squared plus 12 times 3 minus my 13. And when I plug that in, I'm going to get that my y value here is equal to a +5. So that is going to be my k value. So now I have my vertex as a 3, 5. Okay. Now, for example number B, it says the graph of a quadratic function with vertex 0, 1 is shown in the figure below. Find the range and the domain. Okay, so my domain, for the most part, whenever I'm talking about parabolas, it's always going to go between -infinity to +infinity. Okay? Because the x values are infinite in either direction. Now for the range, you just have to be a little bit more strategic. So if I'm looking at the range, remember it's going to be the minimum and the maximum y values. So it looks like this is going to be all of my y values. So it looks like the smallest value, if I follow it, is going to be a -infinity. And the biggest y value looks like it's +1. Okay. So the range is going to depend on the graph. You just want to look at your biggest and your smallest y values. Okay. So for the last practice problem, it says find the x-intercepts and the coordinates of the vertex for the parabola. If there is more than one x-intercept, separate them with commas. So I think the first thing I want to do is find the vertex. And I know to find the vertex, at least the h value, I'm going to use that negative b over my 2a. So here it looks like my a value is equal to -1, my b value is equal to 4, and my c value is equal to a -4. So I'm going to have -2, and I'm going to plug in my a value there. So that b value that I'm plugging in is a 4, and that a value that I'm plugging in is a 1. So when I plug this into my calculator, I have a fraction, -4 on top and 2 times -1 on the bottom. So I'm going to get that as a +2. So my vertex, I have +2, at least for my h value. So to figure out the k value, I'm going to plug in 2 into my original equation. So my y is equal to -x squared plus 4x minus 4. So that value that I'm plugging in is 2. And that's going to give me my k value. So negative parentheses 2 squared plus 4 times 2 minus 4 gives me 0. So my vertex is 2, 0. Okay. And now to find the x-intercepts, remember to find the x-intercept, you let y equal to 0. So x-intercept, you let your y value equal to 0. So I'm going to have 0 is equal to a -x squared plus a 4x minus 4. So what you're going to have to do here to solve for this is you're going to have to factor. Okay. So the first thing I want to realize is that you can always factor a -1 to make your life a little bit easier. You never want the leading coefficient to be negative. So the fact that this was negative here, factor out that negative out. So then now you're left with x squared minus 4x plus 4. Okay. So I'm thinking about factoring this problem, but the more I think about it, well, if I were to do the AC method, I would get this to be a +4 and this as a -4. So there's no way that I can multiply to 4 and add up to -4. Well, let's see. So if I'm thinking about 4, I have 1 times 4 and I have 2 times 2. So I guess -2 and -2 can add together to give me -4, and it multiplies to give you +4. Okay, so I guess it can factor. So 0 is equal to -1, and then I have my x minus 2 and my x minus 2. So that means when I solve for this, -1 is equal to 0. X minus 2, let's try that again. I also have my x minus 2 is equal to 0. So x is equal to a +2. And notice how both of those parentheses are the same. So I just know that x is equal to 2 is going to be my final answer. So then this -1 is equal to 0, that's never possible. So now I know that my x-intercept, if I write it as an ordered pair, because I know I have to, is 2, 0. So my x-intercept is 2, 0. All right. Well, that brings us to the end of this section. And if you guys have any questions or concerns or comments, please feel free to email me. Thank you.